Because I put an A instead of an E on creeping on accident.
Okay, so linear programming is all about this. You're given some functions to graph. A whole bunch of them. And you have to find the point that meets all of those criteria at the same time, and then makes this thing called the objective function. Either a minimum or a maximum. So in this case, we want to find some points x and y that satisfy these 1, 2, 3, 4 inequalities. And at the same time, we'll make this right here, that 5x plus 8y be the biggest or the smallest. Okay? So first thing we have to do is find the points that meet all of these constraints. So how do you graph 2x plus y is less than or equal to 10?
Y is less than or equal to 10 minus 2x.
Y is less than or equal to 10 minus 2x. So that means it crosses the y-axis at 10, right?
Yeah.
And it has a slope of? Negative 2, down 2 over 1, 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 down 2 over 1. Solid line or dotted line?
Solid.
Solid. Okay, and I'm not going to do any shading yet. So do you understand how I graphed that line?
I guess
That's what
so.
we were doing yesterday and the day before. All right, how do you
You know
want?
what you could do to make the shading easier?
What?
So you know what shading is where. Is you just make the shadings.
There's a line. I'm going to do something even cooler here in a minute.
Okay.
You're going to love it.
Okay.
Okay? How about 2x plus 3y is less than or equal to 14?
Y is less than or equal to negative 2/3 y x.
Okay, so Shad is trying to
Plus
solve
14
this
over 3.
in his head. Y is less than or equal to, he subtracted the 2x, got negative 2x, divided by 3 because of the 3 in front of the y. Have to divide the 14 by 3 also, so y is less than or equal to negative 2/3 x plus 14 over 3. What the heck is 14 over 3?
Like 4.66.
4 2/3. Okay? So this is a little bit crazy, but if it's 4 2/3, then I need to go down 2 over 3. Okay, ready for this? I'm going to go down 2/3 and over 3/3. My next point is going to be right there.
Why would you do that?
Right down. Then I'm going to go down 2 over 3, and I'm going to go down 1, 2 over 3, and this is why I do it that way, because now when I go down 2 over 3, you can see where they cross.
Actually, if you would have just gone down 2 over 3 from the second
You know, if I had gone down 2 over 3 from there, I would end up
No,
here.
after second.
Oh, okay. You're right. So I'm going by thirds instead of by wholes when I'm talking about going down and over, just because that worked out to be better. Solid line or dotted line?
Solid.
So there's my second equation. And then the last two are easy. X is greater than, whoops, or equal to
Solid.
0 is where?
Straight up.
Yeah, straight up and down, y-axis.
Nice.
And then y is greater than or equal to 0 is
Straight
going
across.
to be
So not straight.
straight across. It is straight, it's just not vertical. Bam! Okay, so now what I want to find is I've got to be below the green line.
Got it.
Okay.
I've got to be below the red line.
Got it.
And above the,
Why? It's that little pentagonal
Yeah.
so
thing.
this little deal right here, right? So the way that I'm going to shape that, which is way cooler than what Bobby's idea was. Like
Ah. Where?
pretty nifty, huh? have. Don't you wish you had iPads and you could do those things? Okay, so to go back to what the problem is asking, they're saying find the point in this shape right here, well 2 points, that makes this objective function the biggest value you can get and the smallest value you can get. How many points are inside this region?
A lot.
How many exactly? Yeah, an infinite number of points, because points have like no size, right? So you can do any decimal number that you wanted. So how are we going to plug in all infinite points into this thing and figure out which one works best? Well, you're not, because there's a thing called the corner principle that says that any point that's going to be either the biggest or the smallest for this is going to be one of the corner points.
Go to that one.
Okay? So the only ones we need to check are these 4 points.
Actually, that one right there.
So this has the coordinates 4, 2, right? This has the coordinates 5, 0. This has the coordinates 0, 0, and this has the coordinates 0, 5. Okay? So if I plug 0, 0 into...
0, 5, no. Yeah.
If I plug 0, 0 in there, what do I get?
0.
0. So obviously that's going to be the
What are you
smallest,
trying to
right?
get?
25.
I want to know the biggest and the smallest. So we have 2 answers. If I plug 5, 0 in here, 5 times 5 is 25, plus 0 is 25. If I plug 4 and 2 in there, I get 36, bigger, nice. And if I plug 0, 5 in there, then I get 4. Okay? And so the minimum would be this right here. The maximum is this right here.
All that was one problem.
Yep. All that for one problem. Okay? So what this is all about is, you know, it's a real world thing, and this thing right here is supposed to be like, there's a couple word problems here where you're trying to figure out the cheapest amount of fertilizer to buy, or there's another one where you're supposed to figure out what kind of paper to buy, or how many hours the factory is supposed to operate. And so if you were trying to maximize this function, probably that function would be something like profit, right? You're saying like, trying to give you like a real world context for this?
What was the last word you said? Profit?
Profit, right? So you want to try and maximize your profit, or what would be something you would try to minimize? Really? Like your costs?
Okay.
Yeah, money distribution, something like that. Okay?
Okay.
So you're going to need graph paper for this. You going to do another one, or do you feel good about that? Feel pretty good about it? So you're just graphing doing just what we were doing the other day, graphing the equations. Okay? Finding the little fun shape that it makes, and then plugging in all the vertices, basically all the corner points into the thing that they give you. And it might not say to find both the maximum and the minimum. It might say, oh no, it's going to say find both. Okay? All right? And they're pretty short problems, so I'll give you a lot of the work on that.
One. Love that. Oh yeah, I'm not going to give you that. Easier on the eyes. I mean, the small one is great. Now,